This time we're answering the question, how does the internet work? The term internet is a shortened form of the two words interconnected and network. Networks are things that are connected together. They include railway and road networks, electricity networks like the national grid, and the networks of nerve cells found in your brain. And a computer network consists of two or more computers linked together so that data can pass between them. In fact, the simplest example of a computer network is just two computers connected with a cable. And by just doubling this setup, by having two pairs of computers connected, you've created an interconnected network, which is a very small version of the internet. In reality, though, the internet is made up of billions of computers and devices all over the world that are all interconnected, which means that a photo taken on an iPhone in Mexico can be on a laptop in London just a second or so later. To make this happen, we need three key things. 1. A set of rules dictating how the data being sent and received is packaged. 2. An interconnected network over which the data will be sent. And 3. A way to route the packaged data across the internet from the computer that's sending it to the machine that needs to receive it. The set of rules that the majority of us use for packaging and moving data around the globe using the World Wide Web is the Hypertext Transfer Protocol, or HTTP, which you usually see at the start of a web address, although there are many others. The first step in the process is that the computer or mobile device that's going to transmit the data, for instance the iPhone with the photo in Mexico, connects to something called a point of presence, or POP, which allows the device to connect to its Internet Service Provider, or ISP. All POPs are connected to network access points, or NAPs. Then these NAPs all over the world are linked together through an ultra-fast connection called the Internet Backbone. These different entities can be compared to post offices and sorting offices in the postal system. The post offices, POPs, are where local network traffic is collected, while the sorting offices, NAPs, are where the national network traffic is sorted. But how is the data actually transmitted? Because it's not practical to send data in one big chunk, your computer chops files into a series of smaller pieces called network packets. These are each wrapped up, addressed and sent individually, along with instructions explaining how to reassemble the packets to recreate the original file. A helpful way to think about this is to imagine that you're trying to send a huge mosaic in the post to your grandma. Fully constructed, it's too large and too fragile to be posted. So instead, you dismantle it and send each tile individually, along with 2 bits of critical information: the address where your gran lives and the plan for the mosaic so she knows where each piece goes when she puts it back together. Network packets are treated in exactly the same way as your grandma's mosaic, but rather than going through the post, they're sent from your computer to your ISP's POP and then onto the internet. The address they have written on them is called the IP address, which is a unique number a bit like a postcode that identifies the computer or device the packets are being sent to. Each packet is guided to its destination address through the internet by a series of specialised computers called routers. These routers are the internet equivalent of staff in the post offices and sorting offices. They look at each packet of data, read the destination IP address, and make sure that that packet then gets put into the right backbone connection for its destination. This process is then repeated until each of the packets gets where it needs to go. And when the packets are received, they're reassembled to form an identical copy of whatever was sent by the original computer, whether it's a spreadsheet, a picture, or a video, in fact anything that you could look at, hear, or use on your computer. Most of the internet backbone is made up of very fast, high-capacity fibre optic cables that can transmit large amounts of data very rapidly. But for most people, the journey your data takes across the internet usually begins and ends in copper cables that connect your home or office to your ISP's point of presence. And because transmission speeds in these lines are much slower than in the fibre optic cables that make up the internet backbone, the majority of the delays in downloading or uploading data occur within just a few miles of where your server is sitting. So if